we're going to discuss what the stone does. We're going to look at allocating resources, arbitrating concurrency, recoverability, garbage collection, communication. So these are some of the things that the stone does. Resources. What resources does the stone allocate? Well, object IDs. Okay, we discussed earlier that one of the things that Gem does is it assigns an object ID to a new object. But you can't have two gems assigning the same object ID. So the stone coordinates the list of object IDs. The gems request a list of object IDs from the pool. Say, could you give me some objects, object IDs? I want to be able to assign them to objects. So the stone is the only one that can distribute object IDs to gems, and so the stone does that. The gems also can request page IDs. Again, page IDs are where we put the objects, on pages, but we have to have a page ID so that only one gem is putting objects on the page at that time. Okay? So the stone keeps the list of free pages, and the stone is responsible for distributing the page IDs out to the gems. The gems request pages. The stone manages the lock requests. So when you're asked for a lock, the stone is the one that says yes or no. Because again, the stone, it needs to be only one allocated at a time, so that has to be single-threaded through someone. The stone manages that. The stone also manages what we call gem-to-gem communication. So one gem can send a message to another gem, but it doesn't know where that other gem is or what IP address it's on and that sort of thing. So that communication happens through the stone. You can send messages from one gem to another. This isn't real commonly done, but there's times when it's useful, and the stone coordinates that.
What would be a reason for one gem to send a message to another gem?
It could be, you're holding a lock that I want. Are you really using it? You could get notified as a gem, someone else is waiting for the lock. So we could actually put up a message on the screen saying, are you going to do something soon or not? And if not, you're going to lose this. And your changes will get lost, and we'll refresh it with somebody else's changes. You could also set up kind of server processes. Imagine a gem whose job is to do some background processing. Well, one way to communicate a task would be to write it to the database in an RCQ, and then this gem monitors the RCQ. And that would probably be the right way to do it. But you might have some operation that you don't want to go through a transaction. For example, you might have unique purchase orders. You might want purchase order numbers to be allocated sequentially without duplicates, without gaps, but you wouldn't necessarily want to have to do a commit to get a purchase order number. You might want to request a purchase order number and then fill out the purchase order and then commit it. The stone manages the commit process. We've already discussed the commit process in some detail, but again, the stone holds the queue of gems that are requesting the commit token. The stone sends the commit token to the gem. Gems will ask for the lock set. The stone is managing that, so the stone will send that to the gem. The stone also might manage a write set union. So if the gem is on a remote host, then it won't be able to see the write set union. So the remote gem might have to request the stone send the write set union. Then the stone writes the transaction log entries from the gems. And there's something we haven't discussed. Gems can register to be notified when an object changes. So you can, with each gem, have a set of objects and tell the stone, anytime anybody modifies any of these objects, let me know. So the stone manages that and notifies gems that are watching. The stone supervises but doesn't actually do the garbage collection. For example, each commit record contains a list of the pages that have been shadowed. You can't reclaim those pages yet because someone else might be looking at that commit record. So the stone manages the commit record backlog. And when a commit record is no longer needed, then the stone handles assigning the reclamation process out. So it takes the pages that were in the commit record and moves them to the GC gem, saying, this commit record is no longer needed, now you can start working on it. When an object has no references in the repository, Stone actually does some querying of gems saying, we are interested in garbage collecting this object, and there's no persistent references to it, but we're just curious to know if you're planning on making any changes to it, or if your commit will make any changes to it. So the stone manages that. The stone manages the commit record backlog. And again, a gem can configure itself to say, I'm interested in being notified if I'm holding the oldest commit record because I'm willing to give it up. I'm willing to do an abort. So the stone sends a signal to the gem, to certain gems that are configured to request it, saying, please do an abort. The stone manages checkpoints. Checkpoints flushes all the dirty pages from the shared page cache to the extent, at least all of them associated with a particular checkpoint, a particular commit record. Records the event in the extent and the tran log, so that if the system crashes, we can know which checkpoint we were on, and we can know that all the pages associated with this particular point, this particular commit record, all the pages from here and earlier are written to the extent. Stone manages that. The checkpoint is used for the startup after a crash, so we can identify a consistent view. It won't be the latest view, but it will be a consistent view. We know that we have a consistent view. We know which commit record is identified with that. And that will give us a point to say, okay, from this point on, we have to go to the tran logs. Or if you don't have the tran logs, then we'll just start from this point with a consistent view, having lost some. But if you have tran logs, we can replay them from that point on. There are triggers for when to do a checkpoint. We can do a checkpoint every certain number of minutes. We will do a checkpoint when we start a new log, because that way the log, we won't have to use 2 logs to recover from a particular checkpoint. We'll only have 1. We do a checkpoint when we start a backup, because again, we want to be able to have a consistent view for the backup, and then we'll use that checkpoint as the consistent view. And then we can explicitly request a checkpoint. So there's a message that you can send to the system that just says, do a checkpoint. You should not make a copy of the extents unless you've sent the message, suspend checkpoints.
Which is what the online backup is.
Which allows you to do an online backup. And so the online backup is suspend checkpoints and then make a copy. And so actually what would be commonly done is you would do an explicit checkpoint so that your extents have a recent consistent view.
Finishes.
Before the backup starts. And then make a copy of the extents, and then you say resume checkpoints.